pictures, portraits, reflections of the past, glimpses of moments frozen in time, a time of challenges met, a problem solved by the Army Corps of Engineers. The Corps works in both the military and civil work areas, either directly or through contracts supervised by the Corps and performed for the Army and Nation by the Corps laboratories, industry, state agencies, and universities. Corps civil and mechanical engineers produced the Army Mobility Model, which contributed to the design of the suspension system for the XM-1 tank. The Army Mobility Model is also being used to evaluate the performance of vehicles to travel cross-country and to design counter-mobility measures. Knowledge of the terrain gives our troops a decided advantage. New methods are being developed by Corps computer scientists to rapidly provide our ground forces with updated map information so troop movement can respond quickly and with ease. The computer can also analyze terrain that is not visible to the eye due to clouds or other factors limiting visibility. Photo enhancements enable better identification of equipment, weapons, and ground facilities. Cold weather military operations pose problems which the Corps' R&D program is solving. One of the most difficult is the icing up of helicopter rotor blades. The Army's Aviation R&D Command and the Corps' Cold Regions Laboratory are working together to limit the icing of helicopter blades. Through research, they determine the physical properties that cause ice to form on and adhere to metal surfaces in extreme cold weather. Many of the Corps' projects are designed to improve Army garrisons and installations, each almost like a city. And like any large city, military bases have their share of problems. A major concern in all construction is quality control. A new Corps development which is being tested in this area is the Well Quality Monitor. The Well Quality Monitor was developed to ensure integrity and uniformity of wells. This research will help set standards which will assure structural stability. Corps mechanical engineers are also studying heating, air conditioning, and ventilation. This test facility allows the comparison and efficiency rating of temperature control systems and insulation materials. This is one of the largest shake tables in the United States. A computer controls the table and is able to simulate a multitude of vibrations from an aircraft passing overhead to an earthquake. It allows three-dimensional vibration testing for earthquake stability.
Are you ready and tested?
The research and development mission of the Corps includes helping to improve your life and the environment of the country through the development and use of new technology, techniques, and materials. For example, along the nation's coastal regions, the Corps is continually working on ways to stabilize beach sand with vegetation, dune construction, or structural means when necessary. Many of the models sprawl over acres of countryside. Others, like this one, build giant buildings. They are used to study water resources, the navigability of our rivers, ways to improve flood control capabilities in every area of our country, and ways to protect harbors. This is a scale model of Oceanside, California. Here, researchers collect data under controlled conditions, which is then used to make recommendations on seawall construction, docks, piers, and shoreline erosion, so that harbors will be more usable. The Corps' new ice engineering facility is being used to simulate frozen conditions on our waterways. research is focused on cold weather phenomenon such as the destructive forces of ice. Some engineers study the formation of ice jams to find solutions for winter navigation problems. Other engineers in the Corps study the effects of ice on structures and related facilities. In this test, a large sheet of ice is being dragged against a calibrated device, representing a structure to develop improved design criteria. The United States Army Corps of Engineers finds no problem too big, none too small for it to tackle. They are the problem solvers. People working on a variety of research and development projects in a variety of places. Finding answers.